Section 4.8 is probably one of my favorite sections in the entire course because it, for the first time, tries to go through and help us to understand this energy conversion process. One thing that I want you to take away from this course is that all electrical machines are energy converters. They convert electrical to mechanical or mechanical to electrical. We'll leave transformers out of the discussion for the time being, but they all are energy converters. So how does that actual energy conversion take place? How is it that we are able to take a mechanical input to a generator and mechanical energy input to a generator, and on the output side of that, have electrical energy? And it's I think it's really interesting, and I think it's a neat to just know that because it is interesting, but it's also important from another standpoint in that it helps us to understand applications and troubleshooting and other aspects of electrical machines. So let's look at that at some detail. Up to this point, we haven't actually done anything useful with this generator because we haven't connected anything to it. So finally, we're going to do that. We're going to put this generator to work and we're going to connect a load to it. And that load is represented here. And what we're looking at here, it's just represented by like a resistance or something, some resistive load or whatever. But, it could be much more complicated than that. It could be anything that we know that could serve as a load to a generator. Anything that's ever connected that receives electrical energy, lights and anything that we connect to it. So when you connect this DC generator to a load, there's this relationship that takes place between the flux and current that's flowing, and he calls it this mechanical electrical energy conversion process. So the easiest, simplest thing to do is to look at a two-pole generator again, and it's being driven, mechanically. Something's causing this armature to rotate, and it's being driven in this direction, counterclockwise, as we look at it. This is figure 413 in your textbook. Now, current is delivered by the generator. It also flows this current, and maybe you know this or you hadn't thought about it or anything, but the current that is flowing in this generator flows through each of the conductors, right? So each conductor has current flowing through it. Now, if we could look inside the machine, we would find out, and you could break this down in a physics course or whatever as to why this happens. But I mean, even in our courses, we talk about this in ELC 131 and ELC 133. But just for the, for not to redo all that at this stage, but just know that conductors that are all exposed to the North Pole here would have current flowing in one direction. And that's indicated by the small dot in here. And if we thought about that, we might think about an arrow, right, with a point, coming toward us. We could think of it in that term. All the conductors under the South Pole would have current going in the opposite direction, going away from us. So if we look at current in the North Pole as coming toward us, current in the South Pole conductors would be going away from us. So, that's what he's indicating with these pluses, which is, we think about that being the end of the arrow into the South Pole and the point coming to us on the North Pole. Okay, so all the currents have that particular direction because of their being under the North of the South Pole. Because these conductors, which are current carrying conductors, are exposed to a magnetic field, they are subjected to a force, which, this has been mentioned before in other places, and I will do a side video and explanation about this uh, phenomenon called Lorentz forces. But Lorentz forces say, basically, and we'll quantify it with these, look backs to chapter 2. This is some of that chapter 2 stuff that I was telling you we'd have to go back as it came up. But what it says that anytime a current carrying conductor is exposed to a magnetic field, it will experience a force. Okay? Now, if we went through, and there's some basic things that we can do to understand the direction of that force, but just for discussion's sake at this stage, let's just say that this is the force exerted on each one of these conductors, and it's shown here in relationship to the position of the conductor. And so there's a force that's created because this current carrying conductor is exposed to a magnetic field. Well, look what happens to these conductors. All of them have these forces indicated, and notice that in totality, they're all in the same direction. They're all going in this direction, okay, across there. And it just so happens that on the other side of this, where the current's going away from us, there's a Lorentz force created on those conductors as well, and they're going in this direction, which, when you look at it, as opposed from one side of here to the other side, it's the opposite. But when we look at that in total, we see that those forces are additive in the fact that they're all going in the same direction. And there's a torque that's created due to these Lorentz forces. All right, so we want to think about that and think about that in terms of this energy conversion process. So here's this rotation of this generator in this direction, and there's this torque or twisting force due to these Lorentz forces that are opposing that. So the individual forces, this combined torque, acts opposite to the direction that the machine is being rotated. So in order to keep this generator turning, we have to exert a torque on the shaft to overcome this electromagnetic torque. That is the key to this energy conversion process. This resulting mechanical power that we have to supply to keep this generator rotating to oppose the electromagnetic torque is the mechanical portion, or the mechanical energy input. And this mechanical power is converted to electrical power, and that's what we end up delivering ultimately to the load. And that's the fundamental idea about how energy is converted from one form to the other. And remember this, and it's key to all of the electrical machines that we talk about. There's this medium that was used to allow this energy conversion process to happen. And that medium that we used was magnetic flux. There was not just instantly creating mechanical energy to electrical energy, we had to use this thing in the middle, this medium, to allow that to happen. And that's the basic operation of all electrical machines.